Alright, this is chapter 2.2, solving systems using elimination. Problem 1. Alright, so elimination, basically what we're trying to do is look for a pair of variables that cancel each other out. Like if this was a 4 and this was a negative 4 down here, if we added them together, 4 minus 4 is 0. Or this is a 3 and this happened to be a negative 3. Now, none of that is true in this case, but that's what we're looking for. Alright, so problem with this is the z's are all different. Alright, the y's are both different, so they don't cancel out. And the x's are all different. So what we're going to do is we're going to rig it. And I notice that this negative y, if I multiply it by 2, it becomes a negative 2y, right? So 2 minus 2 would be 0. So here's how I go about doing this. Alright? If I multiply the entire equation by negative 2, not negative 2, positive 2, both sides, alright, here's what I get. I get 12x minus 2y plus 8z equals negative 6. And now, I'm just going to bring this one down, alright, just so you can see them next to each other. 4x plus 2y plus 3z equals 12. Alright, notice how I've got a negative 2y and a positive 2y. I've got those guys right there. So, if I add the two equations together, 12 plus 4 is 16, so that's 16 x's. Negative 2 plus 2 is 0, so the y's go away. They become 0. 8 plus 3 is 11, so plus 11z. Alright, and negative 6 plus 12 is positive 6. Okay? So I have an equation, and I eliminated a y. That's why this is called elimination. I added two equations together in such a way that one of the variables, in this case the y variable, disappeared. Now I can do that with any variable I want. So for example, this could get very, very convoluted, but if I multiplied this by 4 and this by negative 3, this one would become a 12, and this one would become a negative 12. Alright, and that's pretty convoluted, and that your numbers get pretty big, but it would work. Alright, it's just more work to do. So now that I've got it down to one equation, notice how I've got this one up here that doesn't have a y either. So let's write it right here. I'm not doing this. It doesn't have a y either, but the x's are both 16. They're both positive. So if I do 16 plus 16, that's not 0, that's 32. So what I'm going to do is I'm going to multiply this one by a negative 1. A negative 1 because negative 1 doesn't change any of the numbers, however the negative changes the sign. So negative 1 times 16 is negative 16. Negative 1 times 5 is negative 5, so it's negative 5z. I forgot my little x right there. And negative 1 times negative 6 is positive 6. Alright? Now when I add these two together, I'm eliminating an x. 16 minus 16 is 0, so those go away. 11 minus 5 is 6, so that's 6 z's. And 6 plus 6 is 12. Divide it on out, z equals 2. Alright? And now that I've got that, they just kind of cascade down. I can plug this 2 right here into any z in this whole system that I want. Any of those z's I can plug it in, and it's perfectly valid. So I'm going to choose, let's choose this one right here. Choose that equation. Alright? So 16x plus 11 times 2 equals 6. So that's 16x plus 22 equals 6. Subtract the 22, 16x equals negative 16, x equals -1. Yay! Now I've got 2. Now to get a y, I simply have to plug that into 1 where I get a y. And there's none where it's already solved for, so I just got to pick one. Let's choose, I don't care, let's choose the first one. Why not? Let's choose that first equation. Haven't used that in a while. So 4x, that's -1, plus 2 times y, plus 3 times z, which is 2, equals 12. So it's -4 plus 2y plus 6 equals 12. So if I subtract the 6 and add the 4, 12 minus 6 is 6, plus 4 is 10, so 2y equals 10. Alright, just so write it out what I did. I did a -6 and a plus 4 to get rid of both of them. And so y equals 5. So my ordered triple for this equation, the solution would be -1, 5, and 2. There you go. Let's pause, and I'll move to letter B. Alright, letter B. Letter B, the first thing you may notice about letter B is all 3 equations have 3 variables. All 3 equations have 3 variables. So, what we have to do is we have to get rid of y or x or z twice. We have to get rid of our first variable twice to build the 2 new equations. Okay? So, the first one I see is, well, let's look at these all together so that we can kind of evaluate them. X's. You notice how these are all very different? To get these all to the same number, I'd have to multiply the 8 up to a 24 before I can get all 3 of those to 24. And that's pretty high. Alright? Skip over the y's real quick. I'm going to go to the z's. The z's, I got a 2, a 15, and a 3. Well, I'd have to multiply. 2 does not go into 15. So I'd have to move 15 up to a 30. 2 goes into 30, and 3 goes into 30. So I have to multiply everything there to get up to 30 to get rid of it. Alright? So that's the process I'm going to choose what I'm doing. And you may have already realized that the y's, well, I already have 2 6's. If I multiply that by 6, I will have all 6's. So I want to get them to where they have all the same number, but different signs. Well, obviously 2 will have the same sign, but 1 will be different. So here we go. I'm going to start off by just combining these 2 right here. Okay? So, -3, 8 minus 3 is 5. So I got a 5x. -6 plus 6 is 0. 2 minus 15 is -13. Z equals -20 plus 51. That is -31. Okay? All I did was combine these first 2 to get rid of y. Alright? Now, what I'm going to do is I'm going to have to rig the second one to get rid of it. Alright? So I got this -6, and I got to rig that to get rid of them, to get rid of the y's. So first things first, let's move this over to where I can see it. 8x minus 6y plus 2z. Z equals -20. Alright? So what I'm going to do is I'm going to multiply, clean this up a little bit, I'm going to multiply this equation down here by +6. I don't need to change the sign, I just need to change the number. Alright, the signs are already opposite, so we're good. So distribute all the way across. 2 times 6 is 12, so that's 12x. 6 times 1 is 6, so that's +6y. 6 times 3 is 18, so that's +18z. And 6 times 0, well, that's still 0. The only number that doesn't change. Now let's add up. 18 plus 12 is 20, so 20x. -6 plus 6 is 0, so no y's. 2 plus 18, well, that's 20z equals negative 20 plus 0. Well, that's negative 20. And yeah, let's go ahead and simplify that. I can divide all those by 20. So x plus z equals negative 1. And just again to reiterate, I divided all these by 20 all the way across just to simplify the equation a little bit. Cool? So now I'm down to two equations. Both are missing a y. I got this one, and I got this one. So I can get rid of either variable. We can either go for the x's. I'd have to multiply that one by 5, or actually a negative 5, to make it the opposite of this one. Or I can get rid of the z's. I'd have to multiply this one by 13 to get them opposite. And again, you can do the 13, but I'm going to do the 5 just simply because I don't have to multiply by as much. So here we go. Let's multiply this one by 5. Oh, come off it. Negative 1 times 5. Alright? So, 5 times x is... Oh, I have to multiply by negative 5. I apologize. Because I got to change the sign. Mr. Hunter, you have to change the sign. My really bad accent. So, negative 5 times x is negative 5x. Negative 5 times z is negative 5z. And negative 5 times negative 1 is positive 5. Okay? So here we go. 5 minus 5 is 0. Negative 13 plus 5 is negative 18. And negative 31 plus 5 is negative 26. Pause for just a second. In doing this, you may have realized that my version is different than yours. I just realized that there's actually a typo in this. This should be a positive 20 right there, which really only makes a little bit of a difference. That makes this a positive 20, this a positive 20, and this a positive 1. So that when I come over here, it makes this a negative 5. Okay? This should give me the answer I'm looking for. So negative 31 minus 5 is negative 36. Okay. And then negative 36 divided by negative 18 is positive 2. Nope. Let me fix this one more time. The problem is right here. The very, very beginning, I did negative 20 plus 51. Negative 20 plus 51 is not negative 31. That is positive 31. Alright? Which means 31 plus 5 is positive 36. Z equals negative 2. That is correct. Alright? So, let that be a lesson to you. Be careful of what you do. And if you get the wrong answer, you got to go back and look for it. Thankfully, I found it. So I don't have to redo both of these problems for this video. Alright? But so far, this is the correct work. This is what you should be looking at. Okay? But now that we've got the z, just plug it in to get x, plug it in to get y. So I'm actually going to use this equation over here, since it's the simplest one. So that's x plus, well, negative 2 equals negative 1. If I add that to, x equals positive 1. Which that's the correct answer as well. I'm glad I have the solution to look at over here to make sure I do things correctly. I don't have it worked out, I just have the answers. And then last but not least, we can pick any equation we want. I'm going to do that first one. And something just went really good in the baseball game over there, so I'm going to be checking that out real quick. I'll be right back. Alright, I'm in Maryland right now with my wife's family, and they're watching the Orioles play. And they just hit a home run. They're huge Orioles fans. Which makes me an Oriole fan too, but I'm mostly a Ranger fan still. Anyways, so we've got X, we've got Z. So let's use the last equation. I'm going to use that one over there. So I've got 2x, so 2 times 1, which is just 2, plus y, plus 3 times z, which is negative 2, equals 0. So that's 2 plus y minus 6 equals 0. Move the 6 over, move the 2 over. What? 2 minus 6 is negative 4. Move the 4 over. Y equals 4. So your solution is x is 1, y is 4, z is negative 2. That is your ordered triple.